Welcome back to Why This Universe. Today's episode is the third and final one in our mini-series we're doing on life in the universe. We've already talked about life on different planets and the search for exoplanets, and we talked about intelligent life and Fermi's paradox, the question of why we haven't met aliens yet. But today's episode is just full-on science fiction meets science. We're going to be talking about this one very special scientific paper written by Dan that tries to address a question that I've never even considered before with regards to civilizations in the far future. And this is the question of how a hyper-advanced civilization would cope with and try to resist the expansion of space due to dark energy. Just a soft content warning on this one that we're going to be talking about the eventual death of the universe and of life. And so if those topics make you anxious, just be warned. That being said, this is one of my favorite episodes we've recorded so far, so I'm really excited. Let's get started. You're listening to Why This Universe, a podcast where we break down the biggest ideas in physics. My name is Shalma, and I'm a PhD student at NYU.
And I'm Dan Hooper. I'm a theoretical astrophysicist at Fermilab and at the University of Chicago.
Okay, Dan, so let's start by talking about what is an advanced civilization?
Yeah, so what I have in mind in the paper is something that at least I think we're capable of imagining, but that is wildly more technologically advanced than human beings at present are. So I'm imagining a civilization that has basically limitless ability to control their environment. Any energy that exists, they can put to use, and they can do basically anything they want with that energy that's compatible with the laws of physics. This is a truly staggering technological achievement, something that, I could imagine our successors reaching in many thousands of years or something. But, it's the equivalent of, hunter-gatherers imagining the 21st century. Here we are in the 21st century imagining something, maybe that kind of leap forward in terms of progress. So I don't know what a hyper-advanced civilization will want to accomplish. Maybe they'll want to terraform planets to be like perfectly inhabitable. Maybe they'll want to create giant computer simulations where they can live in paradises. Maybe they'll want to solve currently unsolvable math problems. Maybe they want to ponder deep questions of philosophy that are beyond us. Maybe they want to make art. I don't know. Who knows? Any of these things or combination of these things are all possible, and many things I can't even think of. But all these things have something in common, which is they all require usable energy. Energy to just to power thought, energy to power computation, absolutely anything you could imagine a hyper-advanced or not particularly advanced civilization wanting to do requires energy to do it.
And when we say that we need energy, even just to power thought, we literally mean that, you need to eat some food to keep your brain active. It's that basic. We need energy for anything. And by usable energy specifically, we're hinting back to our episode about entropy in the era of time. That was episode 14. While energy as a whole is never created or destroyed, we need the energy around us to have low entropy to be usable. For example, I can eat a banana, and that's going to give me some good glucose that my body can break down into usable energy. But once I sweat out the energy of the banana during a warm-up, that's no longer usable energy. That's just waste heat radiating off my body, and I can't really do much with that because it's too high entropy.
So let's think about what forms usable energy take in the universe. From a human-centric perspective, modern human history, the Industrial Revolution, and what has followed has been powered by things like fossil fuels, along with, wind and hydroelectric power and things like this. All of that stuff really, though, boils down to Starlight. I mean, all that oil we're extracting from the ground, I mean, these are from fossilized animals that basically all came down to photosynthesis at some point. So sure, through a complicated organic process, that Starlight was bottled up in fossil fuels for our later use. But ultimately, it's just Starlight is where that energy comes from. Plus, it's like worth appreciating that all the fossil fuels in the Earth's crust is just nothing compared to the amount of sun, the energy the sun is putting out in any given moment. So if you're really thinking big, if you're thinking about a civilization that can control its environment in a profound way, fossil fuels aren't the answer. That's just a few drops in the bucket. It's really harnessing the power of their star or stars that the action is going to be at. That's where the power that can drive this sort of civilization or power this sort of civilization would really come from. There's some other ideas that both science fiction writers and scientists have talked about in terms of ways you might extract energy. There's something called the Penrose process for extracting energy from a spinning black hole and things like this. And there could be lots of energy there too. And I'm totally open-minded to the idea that an advanced civilization might find black holes and tear energy out of them through this process. But I'm pretty sure that if such a civilization ever existed, that Starlight would play a pretty big role in their overall energy budget. That seems pretty clear to me.
Okay, so when talking about civilizations much more advanced than we are, it's useful to have some way to characterize them.
So sometimes people talk about advanced civilizations in terms of something called the Kardashev Scale, named after the Soviet astronomer who proposed the scale back in 1964. He had a few different tiers. The first one was a type 1 civilization, which would be a civilization that can store and use all of the energy that's produced in their planet. So in the case of Earth, if you used all of the energy that's available in all forms, you could get about 10 to the 17 watts of power in this way. That would be what we call a type 1 civilization. For comparison, we use currently about 10 to the 12 watts. So we could, without going beyond the Earth, increase our total energy output by something like a factor of 100,000, hypothetically, if we did everything just right.
So we're not even type 1 yet.
We are not even type 1. We're a long way from type 1. Yeah. Type 1 might, would be way off, Star Trek style science fiction, I think. Type 2 in the scale is a civilization that uses all of the power available in the solar system. So all of the starlight from their host star would be tapped and put to efficient use. Here we're talking like 1 billion times more energy than the type 1 civilization had. And then in the type 3 of the scale, they talk about a civilization that has harnessed the entire power of a whole galaxy. So not only their own solar system, but they've expanded out, tapping into all the stars and black holes and whatever throughout the entire galaxy. That's about 10 to the 37 watts, or 100 billion times more than a type 2 civilization would be able to offer.
I've got to say, I've heard this before, but now I'm kind of picturing it, and I feel like what it would mean for a civilization to use all of the power from a star means that anyone else looking wouldn't really see any of the light from the star, right?
Exactly.
It would mean that the night sky would be dark.
Yeah. So like let's turn that question on its head and just think, what would a type 2 civilization look like? If you're using all the energy from that star, that light's not getting out, just like you were saying. You might imagine they build some sort of giant megastructure surrounding that star that collects all of that light and harnesses it for use. These megastructures are usually called Dyson Spheres, named after the physicist Freeman Dyson. Apparently, Freeman Dyson hates the fact that these things are named after him, so I'll just throw that out there. But all the same, I'd be proud to have a hypothetical ultra advanced civilizations megastructure named after me. But apparently, Freeman Dyson doesn't agree. But there's also an issue of energy conservation. I mean, if this megastructure takes in all this starlight, that energy doesn't just disappear. Even if you use it, it has to go out in some sort of waste heat. After all, like if I burn some coal or something to extract its energy, that energy doesn't disappear. It goes out some sort of smokestack or something, not only emitting carbon in the atmosphere, but also producing tons of waste heat and other unintended waste products. So that Dyson sphere would radiate very, like infrared light or other sorts of not particularly useful forms of light in all directions. So you might imagine a Dyson sphere out there might just look like a really bright emitter of infrared or millimeter wave waste heat.
Okay, so we've talked about this measure for how advanced a civilization is. A Type 1 civilization can extract all of the energy from its planet. A Type 2 civilization can extract all the energy from its star, which would involve doing something like building a Dyson sphere, some kind of sphere surrounding the star that traps all of its energy. And then a Type 3 civilization would expand into the galaxy and be able to extract energy from lots of stars. So now let's just imagine in the future an advanced civilization that can build something like a Dyson sphere.
They, like we said, want to get as much energy as they can, either to use it now or at some point in the future. But, whatever they want to accomplish, they want as much energy as they possibly can to accomplish it to the maximum degree possible. So from this perspective, they would want to expand outward and build Dyson spheres around every star they possibly could, as many as possible, and bring all this energy somewhere so they can do useful things. Again, maybe it's art, maybe it's math projects, maybe it's simulating utopic existences, who knows? But whatever they want to do, they want as much energy as they can, which means expanding out and building as many Dyson spheres as they can around as many stars as possible. What would ultimately limit this process?
So let's say we want to try to answer this question of what would ultimately limit an ultra-advanced civilization from just collecting unlimited amounts of energy. What would be the first thing that you think of? Maybe you think about the fact that, it's really hard to travel anything near the speed of light, so maybe that would just be a big limitation. It would just take too long to get to stars that are very far away. Maybe building the Dyson spheres would be really expensive or would require a lot of, a special material that's hard to find or something. All of these are fair, very practical limitations that may exist, but none of these limitations are, embedded in the laws of physics. They're just things that make the action of obtaining this energy a little bit harder. But it turns out that there is actually something in the laws of physics themselves that sets a limit on how much energy this kind of civilization could collect. And it comes from the discovery of what we call dark energy. This is the energy inherent in the vacuum of space that's causing the universe to expand and expand at an ever-increasing rate.
Our universe is expanding faster than it used to be. And that means parts of the universe that we used to be able to see or get to are no longer accessible, even in principle. So we know that billions of years from now, there'll be parts of the universe that we can see and could travel to today that will no longer be causally connected to our universe in the future.
This comes from the idea of a cosmic horizon. So the idea is that since our universe is expanding at an accelerating rate, there's some distance away from us where the expansion is moving faster than the speed of light. So things at that point in space are moving away from us faster than light. And since the speed of light is the cosmic speed limit, you can't ever travel faster than it, no signal from that point could ever reach us again. And so we'll never be able to see or interact with that region of space ever again. And so we'll become completely causally disconnected from it. If you want to hear more about this and about dark energy, we go in depth about it in episode 10. But anyway, this cosmic horizon poses a big problem for an advanced civilization trying to collect as much energy as possible.
That horizon that separates places that are causally connected and causally disconnected from us is getting smaller as the universe's expansion rate accelerates. More and more stuff is falling beyond the horizon as time passes, limiting this hyper-advanced civilization's ultimate ability to collect and use energy from stars. The ultimate fate of our universe, at least assuming that dark energy continues to do what it's doing now in the future, which is an assumption, but our measurements suggest that something like that is true. It suggests that as the universe expands and expands and expands, ultimately almost the entire universe will escape from our view, falling beyond the cosmic horizon. Something like 100 billion years from now, there will really be nothing but what we call our local group that we can observe. The local group is like the Milky Way galaxy, the Andromeda galaxy, and then a bunch of other smaller galaxies all gravitationally bound together. We can see about 1 trillion galaxies in the observable universe today. Almost all of that will be causally disconnected from us 100 billion years from now. So ultimately, our whole universe, this trillion galaxies that we can see with our telescopes today, almost all that will have disappeared forever behind the cosmic horizon, leaving relatively little for us to observe or interact with or draw energy from.
Yeah, this is depressing.
Yeah, I mean, if you're of the opinion that it would be a good or great thing for intelligence and consciousness or whatever to exist in the universe literally forever, then you have a lot to be unhappy about, because that's just not in the cards. The laws of physics do not seem to suggest that's possible. Consciousness emerged in the universe, at least on Earth, relatively recently under very special conditions. It could not have existed very early in the universe's history. And pretty good reasons for why it can't exist in the very, very, very distant, parts of our universe's future either. We have a window of time where this kind of incredible thing called consciousness can thrive. But yeah, it's not going to last forever. Personally, I'm fine with that. The idea of consciousness persisting forever is really, it creates a lot of anxiety for me. I'm perfectly comfortable with us having a finite, window to do some pretty cool things.
Well, I at least feel like a universe without sentience is a pretty sad idea. I don't know. It's interesting. I feel like normally when we think of death, we think of it as like a very human experience or like very biological experience, but it really is baked into the laws of physics, I guess, that's the reality for anything. Even like a star system is going to die one day just because of dark energy.
Yeah. I mean, it all comes down to entropy. The second law of thermodynamics, which is a statistical law, but one that in the long run holds, pretty ruthlessly, says entropy is always going to increase. And as that happens, we move towards an equilibrium where anything that we would call life, or really anything we might think of as interesting, ceases to take place.
Yeah.
The heat death of the universe.
Yeah.
But in the meantime, a lot of really cool stuff can be done. I mean, I think of the kind of art and culture and philosophy and mathematics and everything that human beings have accomplished over the past thousands of years. And I know that's just a drop in the bucket of what intelligence or consciousness could potentially produce. So I'm really excited about the possibility, likely or otherwise, that some, civilization will reach the kinds of heights that we're describing here, where they can go and harness many stars worth of energy to, create, works of art. I don't want to call it music or whatever, because like maybe they'll be beyond music, but some sort of, I don't know what the medium will be, but it'll be some sort of incredibly sublime, yeah, I don't know. I have no idea what it'll be like, but it will be incredible to the beings who take it in.
So let's go back to talking about what a hyper-advanced civilization would do about this problem. We mentioned that as the universe expands, the cosmic horizon shrinks. And so the number of stars that we can see and that we are causally connected to also shrinks.
And if you're a hyper advanced civilization who wants to build Dyson spheres around as many stars as you can, that means some of your potentially usable energy is disappearing as time goes on. The idea, the analogy I like to use is if we learned today here on Earth that unless we got our hands on all the oil and coal and whatever in the Earth's crust today, it would disappear in some amount of time, we would start digging really aggressively now. We might not use the stuff right away. We might save it for a rainy day or save it for when we have other solutions to climate change worked out or something. But if it's now or never, we would dig into the Earth's crust with much, much more vigor, I think, and grab it before it was gone. And from this perspective, I imagine a hyper-advanced civilization, seeing that the universe is starting to expand at an accelerating rate, would travel out in all directions as fast as they possibly could, building Dyson spheres around every useful star they encountered and using the energy from that Dyson sphere to propel those stars home where they could start to use the energy. All right, so let's talk about how this will work. So I'm a civilization. I've got some Dyson spheres around some stars. I want to start going out and grabbing as many of these stars as I can before they fall beyond the cosmic horizon forever. So if you get to a sun-like star and you could somehow capture all that energy from that star with a Dyson sphere or something like that, and you could use all of that energy and transform it into kinetic energy of the star, use it to accelerate the star, you could accelerate a sun-like star to just over 1% of the speed of light in something like 1 billion years. That's a pretty fast speed. I mean, it's, you can imagine faster speeds, but it's really flying along there. And it goes like the squirt of time. So if you do this for 100 billion years, you could be going, just over 10% of the speed of light. So the longer you do this, the faster you can get that star moving. On the other hand, like brighter stars produce more power. So, you might think you'll be able to get them moving at faster speeds more quickly, but it's also the case they tend to be heavier and therefore harder to accelerate.
So we're imagining moving the stars so that they don't leave the horizon?
That's right. Right. It's because the horizon's moving towards you. Those stars are going to disappear and stop being useful. We're going to bring the stars, or the civilization is going to accumulate the stars, all the useful ones anyway, in their home galaxy, say, something like that.
Do the planets around those stars come with them?
Yeah, I mean, I think they could decide if they wanted to. So probably to build the Dyson sphere, you'd have to take most of the matter in, let's say, one of those stars, like take one of the rocky planets or something. So one becomes the Dyson sphere, or at least the raw materials to make the Dyson sphere, or something like that. Basically, if the planets are useful, they'll take them. And if they're not, they won't.
But there is also the level of if they encounter another civilization. If there's more than one civilization in this universe or within the horizon, then there's trouble.
Yeah, so I've assumed they're not encountering any resistance to this. That's a whole other can of worms, of course. Yeah, just think of all the science fiction writing that could come out of this idea, right? It's limitless. But where I think the line between science and science fiction might be is in science fiction, like the author usually like makes some choices about, this particular civilization has this motive, or this particular civilization or these characters have these technologies in their hands or whatever. I'm doing everything I can in this paper to be as general as possible. I'm saying, well, I don't know what the civilization wants to do. I'm just imagining they have technology well beyond the limits I can imagine, and they want to use it to do something. And I don't even have to say what it is, but anything would require energy, and the more of it, the better. So what would they do? It's a totally game theoretic question, and going and grabbing all these stars seems to be the answer. At least I don't see a way around it.
Yeah. So I guess we'll get to this eventually, but even if a civilization did do that and brought all the stars with the moving Dyson spheres back into their horizon, like there's still a limit, eventually the horizon will shrink and the stars will die. And
well, because the like if the civilization happened to start where we are roughly, or in the local group, the whole local group is gravitationally bound, so it won't be torn apart by the expansion of space. So we if we get things that compact, that concentrated, you can have them forever, but it's going to be a finite amount of stuff and a finite amount of energy to extract from that stuff. So you're right, it doesn't go forever. It definitely can do a finite number of thoughts or artistic projects, or whatever you're trying to do. You can only do it for a finite length of time.
Oh my God, I'm imagining now like another science fiction scenario of like being in that, very late stage universe, like civilization. They have all the possible stars they could have grabbed. They have the finite resources left, and like they're pulling from the finite resources and like figuring out what's worth to put it to, and like making the final decisions of like where the last bit of resources goes. That's a crazy question.
Yeah, how do you use your last 10 to the 20 watts or something? Yeah,
and like,
I don't know.
Because like you'd have to, I guess, if civilization got this far, eventually allow the resources to deplete.
I mean, if you don't use them at all, if you just save them, that means you're not thinking. Like, it puts yourself in stasis.
I guess they could just go into stasis as the way to like preserve the final moments.
I guess, but I mean, but you wouldn't experience them. If you're in stasis, you're not conscious. So like every time you have a thought, you're using energy. Like every time you have an experience.
Right.
So you can't just stretch that forever,
Right. Wow, that's kind of, I really now want some science fiction writers to write a story of that moment.
The decision at the very end. Yeah. It sounds hard to me because like without like badly anthropomorphizing them, I don't know how you have dialogue or something,
Like they're probably not going to speak English, you mean?
Well, they're probably not going to use anything like words, right? And like maybe even like organisms won't resemble anything like what we're thinking of. It might be more like, I don't know, some giant computer with its subsystems talking to each other and whatever. I don't know.
Wow. Yeah, it's really the world of possibilities here. Yeah. But I do feel like most science fiction, I've never heard of a science fiction story bringing it to these reaches and that deals with this scenario. So hopefully this inspires someone to write that.
Every time I've ever come up with an idea for a science fiction story, and I tell some science fiction aficionado friend of mine about it, they're like, "Oh yeah, so and so did that in 1962." Like, there's always this
is like you can't do it once. Like there are like an infinite way that the infinite number of ways to play out, and different people writing with different values, I feel like would come up with a different ending story.
So far I've been very vague about how this whole accelerating the star thing works. And that's because I have no idea how it works. I'm not an engineer, and I'm certainly not an engineer from a hyper-advanced civilization. I'm assuming they're going to be really good at their jobs. Like one idea that I think is straightforward and like would work to some extent would be to build a giant network of mirrors that reflect all of the star's light in one direction. So basically you take the momentum of that light and use it to accelerate the star. Like that would work, but it doesn't work particularly efficiently. After a billion years of acceleration, a sun-like star would only be moving about 1% as fast as in the optimal case. So it's pretty far from the ideal design, and you'd want to do better. But I'm pretty confident these hyper-advanced civilization engineers would be able to do better than the dumbest thing we can think of. In particular, like you could imagine they might take part of the mass of the star and use it as a propellant. Basically, like if I'm sitting on my rolling chair and I have a bowling ball and I throw it in one direction, it propels me in the other direction. Something like that might go on. I don't know, but I'm pretty sure that they'll be able to make something that gets close to the optimal, perfectly efficient accelerating star, even if I don't know exactly how that's going to work. In order to capture a star and get some useful energy out of it, you have to, first of all, you have to outrun the accelerating expansion of the universe. You can't find yourself on the other side of the horizon. You game over if you do that. But also you need to get the star home before it runs out of fuel. Stars don't last forever. The sun, for example, will burn nuclear fusion for something like 10 billion years or so. We're kind of in the middle age of our star's life right now. And bigger stars burn a lot faster, while smaller stars much slower. So there's kind of a trade-off here. The most intense, powerful stars also have a pretty short life. The faintest, weakest stars are also much, much longer lived. So let's put some numbers to this. Let's hypothesize that there's some civilization out there in the universe, and they start doing this roughly now. Okay, and let's say they manage to get near perfect efficiency, and that they can their probes or whatever that are going out and capturing these stars can move through space at something like 10% of the speed of light. I mean, this is just a guess, but it's a reasonable guess, I think, to start playing with. So within the next 10 billion years or so, this civilization can plausibly gather more or less all of the useful sun-like stars. When I say useful, I mean pretty young sun-like stars, out to distances as far as about 120 million light years from their central civilization. That's a pretty big chunk of space containing lots of galaxies. And, you could get a lot of useful energy by carrying out that sort of a program. And basically all those stars, you'd be able to get to their home civilization and extract the remainder of their energy from them. So there's a lot to be gained there. The heavier stars, like I said, run out of fuel more quickly. So stars that are like twice as heavy as the sun, it would only make sense to gather them if they happen to lie within about 30 million light years or so. The ones farther away, by the time you get them home, they're going to be out of fuel anyway. So you want to leave those behind. You want to focus specifically on like these sun mass stars if they're that far away. Lighter stars, they produce a lot less energy, at least a lot less power anyway. So it takes a longer time to accelerate them. So for stars as light as 20 or 30% of the mass of the sun, in 10 billion years, the civilization could basically take all of those within about 100 million light years and start them on their trip to their central civilization, but they're mostly going to still be in motion. The sun-like stars, you can get home pretty quick because there's enough energy to propel them. The heavier stars, you'd mostly leave behind because they're so short-lived. And the lighter stars, well, they'd be en route, but sometime in the next tens of billions of years, I should say, those will get home and start providing useful energy. So it's kind of interesting, but like stars kind of like our own are roughly optimal when you consider all of these trade-offs. They're reasonably long-lived, but they're not too faint. So they're kind of in the Goldilocks zone of utility for this hyper-advanced civilization.
So if some aliens come and try to steal our sun one day, that might be why.
So next, let's imagine that there's some civilization like this, but they started doing this not today or roughly around now, but they started doing it a few billion years ago. So they advanced to intelligence and advanced civilization long before anything like that happened on Earth. And we can ask ourselves the question, like, to our astronomers, what would this civilization look like if it were out there in the universe? Well, first of all, like we said before, Dyson Spheres block out the ordinary starlight from stars. And instead, it emits a lot of infrared radiation or other kinds of waste heat. So we might expect to see where the civilization's vast regions of space containing entire galaxies or even clusters of galaxies where there's a dearth of starlight, or at least special kinds of starlight, the kinds of stars that would be useful to the civilization. And then even more compelling is we might be able to detect large numbers of bright infrared emitting objects. Even better would be if all of these infrared emitting objects were all kind of moving in the same direction or towards the same common destination. Nothing like this has ever been seen, of course, but with new telescopes, we'll be able to look for this kind of thing out to greater and greater distances. And I can't think of any kind of discovery that'd be more exciting and maybe more anxiety creating than to learn that this is actually going out there somewhere in our universe.
Has anyone done a search for this? Or people have done like infrared surveys and there's no peak?
People have certainly done infrared surveys, and there are actually lots of papers about, here's a weird infrared source. Maybe it's a Dyson Sphere. Like there are lots of papers.
So this is like kind of like a popular-ish idea among people who think about this.
Yeah, I mean, I wouldn't say there's not a very, very small fraction of the papers are on things like this, but like there are occasional papers on infrared emission and maybe it's a Dyson Sphere.
Is it taken seriously in general by like the physics community or astro community?
I think it really depends on who you ask. I don't think we've ever observed anything that any substantial fraction of astronomers thought was likely to be a Dyson Sphere. And I'm just guessing here. I have not done this survey, but my guess is if you asked astronomers, like, do you think Dyson Spheres might be something worth looking for if it doesn't cost much, money or resources? I think the answer would be overwhelmingly yes. I think it's a pretty well motivated thing to imagine existing in the universe. And if, our civilization and its technological and or biological successors don't destroy themselves and continue to learn new things and become more adept at controlling their environment and their universe, I mean, it seems inevitable that eventually this sort of structure would get built. A lot of ifs there, of course.
This episode was produced and edited by me, Shalma Wegsman. Research and writing is done by Dan Hooper and I. Dan is a theoretical physicist at Fermilab and the University of Chicago and is the author of many books, including most recently, At the Edge of Time, Exploring the Mysteries of Our Universe's First Seconds. All music in Why This Universe is produced by Jay Kleinbaum. Thank you so much for your support and for listening, and we hope you tune in next time to Why This Universe.